Hello everyone, I welcome you all to Statup Academy, your online gateway to success in ISS exam. This academy basically focuses on ISS exam and is exclusively for ISS exam only. So we have covered the topic econometrics. All of the topics have been covered according to the given syllabus. And now we will move on further to the next topic, which is sampling techniques, which also comes under paper 3, which is of descriptive type. This is also one of the biggest topic, and we will be covering it little by little every day, like we have covered econometrics. And I hope you all are preparing with us, writing along with us, and doing questions, PYQs based on the things that we do in the class. You should start preparing because the time is very less and we have to cover a vast syllabus. And this exam needs proper 1 year for your preparation, and then we also have to revise a lot. You should start preparing from now onwards. If you haven't started preparing, then you should first prepare econometrics, see all the lecture videos that we have given, and then start with this sampling techniques. So, what do we, as students of statistics, we all are aware of what is sampling techniques. We all have heard of this. We all have done it in our classes, but still we remain confused on most of the basics of what is sampling, what is population, what is a sample, and all those basics we will be covering in this class. So today we will start with the basic concept of sampling, which is what is population and what is a sample. And a sample. Population is something that we define that whole of the people, like a world is a population. Or if we are testing workers or in a particular factory, testing something for workers in a particular factory, then all the workers in that factory is a population. Then if we are testing whether in India, if we are testing that India is affected by COVID-19, how many people are affected in India, then all the people who are a part of India or who are Indians are considered to be the population, or those who have been stuck here during COVID-19 is a part of our population. All of the people that are living on this land during that test is considered as a population. A small part of population is known as sample. Like it is very difficult for us to analyze things for every population. Suppose if I have to collect a data, the income of a city. So the population is whole of the city. Suppose that city consists of 10 lakh people. So we will go to every house, collect the data of 10 lakh people. Some of them will say that I don't want to give the data. Some of them will give wrong data according to their income. Some of them won't be available. Some of them might have gone outside. So we won't be able to collect every household data. So we'll pick a sample out of 10 lakhs. We will pick a sample of 10,000, and then from that sample we will collect the data. Those 10,000 people are available and might be given the right answer and are giving the information that we need. So this is sample and population. Population is a bigger unit and sample is a part of the population. So suppose I have to collect the data. Suppose I have to collect the data of people suffering from COVID-19. Suppose this is the data. People suffering from who suffered, people who have suffered from COVID-19. So suppose this is the population. It has thousand and lakhs of people. These dots define people who have, and this is the data of a state, suppose a union territory, suppose we say Delhi. This is the data of Delhi. So these many people are suffering. These many people are there in Delhi, living in Delhi. And out of this, we will pick out a portion of this. This is whole population. We'll pick out a portion of this, and this small portion of the population on which we will run our test is known as sample of the population. It is as simple as this. What is the difference between a population and a sample? In population, we will do complete enumeration, and sample we will apply sampling techniques. What is complete enumeration? That we will analyze every household. Like I have given you the example of 10,000 households. So we'll go to every house. We will get the information from every house or every household. That is a very uh, not convenient task because it requires more manpower, more money, and more manpower, more money, and more energy or resources, which is impossible because 10,000 and in limited time as well. So more time as well. So that is very inconvenient, which is known as complete enumeration. It may give the correct estimation, but it is not convenient for us. So next we'll move forward to this is what is population and sample. Next is there are two types of sampling. Probability sampling and non-probability sampling. Two kinds of sampling: probability sampling and non-probability sampling. What is probability sampling? Where the chances of selecting a unit in the population is equal, and where the population is has equal chances, plus each factor is equally divided in the population. Equal chances of selection, and where the chances of selection, random chances of selections are there, based on convenience. So this is the main difference between probability sampling and non-probability sampling. In probability sampling, equal chances of selection are there, and and the probability is also equal. So probability of selecting a unit is same. Here we will put, let us take the example of probability sampling first. Suppose we have a coin, we will toss it. The two outcomes are head and tail. Head and tail have equal probability of selection, 1 by 2 and 1 by 2. Or we can say 0.5 and 0.5. This is the probability sampling where we are examining our result on the basis of probability. Now we'll come to non-probability sampling. This is the random chance of selection based on our convenience. Suppose we are testing for people having disease, a particular disease. So we will take the people that are selected are based on the convenience that they are having disease. Not every person is selected. The convenience is included in this. Suppose we have to find the cost. According to the cost, we have to analyze the population. So we will take the sample which is very less in number, so that our cost becomes very low. That is also convenience type of non-probability sampling. Okay, so these were the two types of sampling. Now sampling simply is collecting information from the sample, which is a population's unit, and then analyzing those units, and after that the sample is analyzed based on that, the population is analyzed based on that sample. This is known as sampling. If we have to decide whether a city's income is above 1 lakh, or average income is above 1 lakh or so we will take a sample of it, then we'll analyze it, and then we can say that this sample is a representative of the population, and hence the population is also has the income ranging from this to this according to the sample. Now there are types of probability sampling. The first type is simple random sampling. This is again, we will take a sample and we will choose one of the unit, and the probability of choosing that unit is simply equal to the probability of choosing any other unit of the same sample. So equal chances, and hence this sampling is also known as method of chances. Simple random sampling is also known as the method of sampling. Suppose, let us take an example. Suppose we have a population of a class. Suppose we are in a class, and there are 20 students. I am naming them. Let us take 15 students. There are 15 students in our class, and we have to apply simple random sampling from it. So, in order that this population is not biased, or because I am a teacher, I can be biased with respect to one student. So, I will take a box and I will put chits in that, giving the names of the students or roll numbers of the students, and I will pick one chit and take out. That is simple random sampling. That I am unbiased and I am selecting any unit from the sample without my preference, and every student has equally likely chances to get selected, which is 1 by 50. This is known as simple random sampling. And there are two kinds of simple random sampling again. One is simple random sampling with replacement. The first one is simple random sampling with replacement, or we also call it as SRSWR. What happens in this? Suppose, let us take the same example which we took before. We have a population of a class having 15 students. Now I will take out one chit from this, and it comes out to be roll number 12. Okay, then I will see that 12 has come. Then I will put back the chit in the box, and then again I will shuffle the box and then I'll pick the another chit. It can be 12 again, or it can be any other number. Suppose it is 10. That is the possibility. So every time the probability of selection of a unit is remains same, that because we replace the chit again and again. We pick out a chit, we see the number, and then we put the chit back in the box. This is replacement. This is simple random sampling with the replacement. And without the second portion is simple random sampling without replacement. Which is also known as SRSWOR. So again we take the population 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the population, same class we have taken. So now we will take out a chit. Suppose that chit was 3. Now what do we do? That the 3 is taken out, then we are left with the probability of selecting of 3 was 1 by 15. Now we are left with, we will not replace this chit, we'll keep it aside, and then we'll shuffle again in here and we'll take out one another chit. So now I take out 10. 10 gets erased. Now what is the probability of selecting of 10? It is 1 by 14, or simply I can say 1 by 15 minus 1, because we are not replacing the chits again and again from the shuffled box. Once the chit has come out, it is out only, and the rest students are in there. So the probability of selection keeps on increasing as the denominator keeps on decreasing. Okay, so this completes your simple random sampling with replacement and without replacement. Now we will come to numerical portion. How can we solve this, or what is it about simple random sampling with replacement and without replacement? So first we will take simple random sampling with replacement. SRSWR. Let us see that, let us consider that population size is equals to capital N, and sample size is equals to small n. Now population size is also given to us and sample size is also given to us, where the sample found is y1, y2, yn. Okay, so population size and sample size. Now probability of selecting ith unit from the sample is given by probability of ui, unit of ith unit, is 1 upon capital N. This is the probability which we have discussed previously. Now what is the sample, total number of samples which can be drawn from the population? So total samples are n raised to the power small n. These are the total samples. So probability of selecting one sample, or we can say probability of selecting SI, ith sample, is nothing but 1 upon capital N raised to the power small n. Here I goes from 1 to capital N, and here I goes from 1 to capital N raised to the power small n. So this is the crux of simple random sampling. This is how we denote it in terms of notations. Now, simple random sampling without replacement. Or we can say SRSWOR. Here again, we will take the sample Y1, Y2 up till Y small n. So our sample size is small n, and our population size is capital N. These are the two basic structures for both simple random sampling without replacement and simple random sampling with replacement. So now, what is the probability of selecting ith unit at jth draw? Now this is given by that ith unit is not selected at first draw, it is not selected at second draw, it is selected at jth draw. So probability that ith unit is selected at first draw is not selected at first draw into probability that ith unit is not selected at second draw up till probability that ith unit is selected at jth draw, or we can say is not selected at j minus 1th draw. Probability that ith unit is selected at jth draw. This will be it. So in the previous one, the probability of selecting of ith unit ui was 1 upon n, and probability of selecting or not selecting of ith unit will be 1 minus 1 upon n. So we will replace it here. So ith unit in first draw is not selected. 1 minus 1 upon n. Then 1 minus 1 upon n minus 1. Then up till 1 minus 1 upon n minus j minus 2. Then probability of selecting ith unit. 1 upon n minus j plus 1. Plus 2. On opening the bracket, we will get n minus 1 upon n into n minus 2 upon n minus 1 into n minus j plus 1 upon n minus j plus 2 into 1 upon n minus j plus 1. So we'll see that numerator and denominator are getting cancelled in between, and we are only left with 1 upon n. So probability of selecting ith unit at jth draw is nothing but 1 upon n. Now what is the total number of samples here? Because we are not replacing, so we will apply combination. So total number of sample will be NCN, or you can also write it as LN. These are the total number of samples. Now the last thing is probability of selecting one sample or ith sample is nothing but 1 upon NCN for all I goes from 1 to NC. So this completes the basics of simple random sampling with replacement and simple random sampling without replacement. I have told you we are taking this from the very basic. What is sampling? What is population? And what is sample? Then what are the two types of sampling and their further classification? We'll go with this space only. We'll discuss everything in detail, and all your doubts will be cleared in the class only. If you still have any doubts, then you can ask in the comment box. Only relevant doubts will be answered. And I hope you understood today's lecture, and this was the basic of simple random sampling. From tomorrow, we will start doing its derivations and variances, estimation, and everything. And we will also start with PYQs. So keep on working hard. Thank you.